on our screen. This is one of the achievements for our study. We have designed the symbols and colors. The second, we have also defined visual data that should be reported. That we collected some of the very crucial data that should be collected from AIS. And the next one, the vessel shipping in this area should automatically monitor. The warning should be given if they do not abide by the traffic rules. Just before I just mentioned that we have set navigation rules, and the system could adjust whether the vessel is abide by the rule. So if so, that we could send warnings for related vessels. And next, the AIS can broadcast text message, ATOM, water ice, vessel, and the meteorological information. Now some of our AIS stations have now broadcast such information now. The VTS is able to supervise the risks of collision and grounding. Just now I show you the two concepts that we have, the new concept from our study. Also that we have established three-dimensional charts that should be used on our VTS. That's the VTS operators not only see the situation above the water, also the situation under the water. This is very useful for the VTS operators to judge the whole situation. And also all the data and the traffic pictures are automatically recorded and saved in VTS Center, which can be replayed or used for future analysis. Now let's come to the conclusion. Application of the AIS information will greatly enhance the functions of VTS for navigation safety and the efficiency. In addition, workload and human errors shall be greatly decreased. And the new methods can be used for determination of collision and grounding risks of vessels. Thank you. Thank you all.
Thank you for that presentation, Shinji. Now we will move on to our next speaker, Francesco Frau, who has a degree in physics with a specialty in cosmology. Early in his career, he worked in civil and military applications of electro-optical systems. But since the 1990s, he's been involved in experimentation and research on VTS and has designed a number of devices for maritime surveillance, ranging from a mobile VTS unit to AIS and satellite imagery integration into VTS systems. Francesco has been a member of the VTS committee since 1996 and will present on lessons learned in VTM. The floor is yours.
Ladies and gentlemen, let me start by thanking all of you for being here and the chairman for those kind words of introduction. I'll discuss here the industrial vision on the vessel traffic management concept, whose meaning has already been very well explained in the previous presentations. And the vision from the industrial point of view is more strictly related to questions such as how it can be put in practice, how it could affect the existing systems. To answer those kind of questions, I firstly try to give a look around for some examples that may help. I then found examples of management systems based on multilateral agreements such as the reporting system in the Gulf of Finland, or integrated systems, having a network of VTSs as central element, such as the Italian National Integrated VTS Systems or the Automated Radar Surveillance System for the Polish Sea Area or the National Yemeni VTS. Also, some examples of global services may be mentioned, such as SafeCNet or CleanCNet. In all the systems operating in a VTM framework, of which the aforementioned are only some of the possible examples, the need to frame the equipments and their operating functions in a framework or arrangements between the customer and the other stakeholders strongly affects the general requirements for the equipment to be deployed. The first lesson learned is therefore that VTM technical solutions cannot be designed as a closed self-referencing system. The more a system is complex and wide, the more it will need external connections and the more it will be influenced by those. The presentation also is a problem related to the extension and complexity of a system, such as the VTM1. There is a serious challenge in finding a way to display all the pertinent information in a clear way. In similar systems installed up to now, a requirement often received is to provide the higher degree of integration in the presentation area. I expect the same in the VTS case, in which an operator would see on a graphical background information such as track density distribution, the frequency of communications or the services accessible to a selected track. The problem is that as soon the system complexity exceeds the very local configuration, the amount of info exceeds the capacity of a human operator to acknowledge from an all-in-one display representation. And the efficiency of a system will then be related to the capacity to propose the better compromise among integration, thoroughness, and readability. Since our first networked large-scale application of the VTS principle implemented in the St. Petersburg Channel in the middle 90s, that's an example picture. The crowding problem in presentation was evident and required assured solutions such as automatic windowing or smart selection of object categories to be presented. Since then, more than 15 years of specific studies lead to the availability today of very advanced and flexible common sets of presentation functions, well suitable for VTM requirements, but the operating console still remains a relevant matter of competition among the manufacturers. But not only. The use of existing technologies for large scale is another challenge. Another of the lessons learned is that the availability of communication lines of proper capacity may be a serious problem when different means are needed. This happens in very large systems where different connection methods are mixed with each other. Let's think to what happens when internet, maybe satellite, optical fiber protected lines, radio frequency and so on, are mixed in the same link where, moreover, the different means are maintained by different customers which react in very different way to the same requirement. The shape and the rank of the interconnections is the system architecture that therefore must be very carefully designed accordingly with the specific situation. But this includes many more elements than communication. The cartography, as another example, often follows different standards in different applications, and thus requires the development of ad hoc interfaces to interoperate. Interoperability, in fact, is at present a hot concept at any scale, and it's the subject of studies and investigation in many contexts. The lesson learned here is that the level of interoperability requested by the most of maritime users is firmly structured in the sense that any stakeholder is available to share its own data, but only if the exchange protocol guarantees the possibility to decide which data to share and with whom. The installation experience is, in short, in good accordance with the general indications coming from a